Okay, today we're going to work on the third assignment in our packet, binary compounds with transition elements. We are again using the crisscross method. The difference with this versus the other day is the fact we're using the transition metals. If you recall, transition metals do not follow the rules. They don't always give up just their number of valence electrons. Sometimes they give up that number, sometimes they give up more, sometimes they give up less. So to know what the heck those elements are doing, we use Roman numerals to help us identify the charge, that oxidation number. So today I'm going to help you with iron, copper, lead, mercury, chromium, and manganese. If you notice on that page, each one has a Roman numeral. That Roman numeral is going to tell you the positive charges with it. We're going to use the elements iodine, phosphorus, fluorine, sulfur, nitrogen, oxygen, and arsenic as our negative charges or our anions, okay? So let me start. I'll do the same thing I did the other day. I'm going to use iron. Because I'm using Roman numeral 2, it's a 2 plus. I'm going to start with iodine. Iodine is I. It's got a 1 minus because remember it's a halogen, a group 17. It only needs one more valence electron. So I'm going to crisscross those numbers, the 1 and the 2. I'm going to bring the symbol straight down. Because iron has a 1 next to it, I do not need to write that 1. The Fe, the symbol, tells me there's one of them. Then I'll put the capital I for iodine and the 2 next to it in the box, telling me I need 2 iodines to balance out iron Roman numeral 2. So if I do iron again, Fe, 2 plus, and if I do phosphorus, it's a 3 minus. I'm going to crisscross those numbers, bring my symbol straight down. In the box, I need to show that it takes 3 irons for every 2 phosphorus to create a compound. Okay, let's try one more. Let's have Fe, 2 plus, fluorine, 1 minus, crisscross my numbers, symbol straight down. And again, I only write the symbol for iron because there's a 1. That symbol represents that. Then I do the capital F and the 2 to show that it takes 2 fluorines to balance iron when it's a Roman numeral 2. All right, let's continue on. We have Fe, 2 plus. We have sulfur, that's a 2 minus. Okay, crisscross my numbers, symbols straight down. Because they're both a 2, we can simplify and in the box write FeS. Okay, nitrogen, so Fe is a 2 plus. Nitrogen is a 3 minus. Crisscross those numbers. Symbols straight down. In the box, I need to show that each of them have a subscript. There's a 3 next to the iron, and the N has a 2 to balance out to make a neutral compound. All right, let's do Fe, 2 plus. Oxygen, 2 minus. Crisscross my numbers. Symbols straight down, and you guessed it, simplify and write in the box FeO. All right, last one in that grouping is going to be iron, 2 plus, and arsenic. And if you look on your periodic table, arsenic is in the same grouping as nitrogen. It's got 5 valence electrons, so it means it's a 3 minus charge. So crisscross my numbers. Bring my symbol straight down. In the box, write Fe3, As2. All right, you're going to do the same thing with copper. It has a Roman numeral 1, so it's a 1 plus. Lead has a Roman numeral 4, so that's a 4 plus. Iron again with a 3 plus. Mercury with a 2 plus. Chromium is a 3 plus, and manganese is a 2 plus. When you're done with that chart, write out the correct name. This is where you must write out the Roman numeral. You cannot just write the name because we have to know which way is it going. If you notice, there's two irons, iron 2 and iron 3, and it changes the number of atoms you need of the other element to create that compound. So make sure you showcase the Roman numeral. When you're done, continue on with the next page.